Just kind of an add-on explanation here, because I was thinking of different ways that I can connect this to what we did previously with the ancient languages. So if I were to convert, so again, the example here was 927, and we're going to base 8. If we know the powers of 8, right, so we'd have 8 to the 0th, and I'll just kind of write it off on the side here. 8 to the 0th is 1, 8 to the 1st is 8, 8 to the 2nd is 64. So I'm looking for the biggest power of 8 that would divide evenly into 927. And even after, a certain point, you start, sort of relying on calculators. So I'll just do 64 times 8 to get to 8 to the 3rd power. So I'm doubling it 3 times. So 128, 256. I think 512. Let me just run that real quick. Yeah, 512. If I were to multiply that by 8, I'd get something in the thousands, so 4,096 or something like that. So I would start off with my 8 to the 3rd, knowing that I can get one of those. Now, I'm going to pretend I don't see this here, but 8 to the 3rd is 512. If I had 2 of them, I'd be over the target number, which is 927. So then I would take my 927 and subtract from it 512. I'm left with 415, which is too small to get another 8 to the 3rd in there. But what I can do is see how many times I can get an 8 to the 2nd in there. All right? So 8 to the 2nd is 64. So 6 times 8 is 48, right? So if I tried multiplying this by 8, it would be 480 plus another 32, which gets you to 512, right? So I wouldn't want to do that. I'll try multiplying by 7. So 64 times 7, still too big. My target number is 415. So maybe 64 times 6, again, pretending I don't see the answer right in front of me. So I would need 6 of those 8 to the 2nds, all right? So I would take my 415 and subtract off of it the 384. Now I'm down to 31, so 64 is too big. So I'll try to piece together a bunch of 8 to the 1st powers to get there. All right, so I can get 3 of those in there. 8 times 3 is 24. 8 times 4 is 32. That's too big. All right, so I'll go to 24. So subtract off the 24. Oops, got to get a little answer in here first. And that'll give me 7 single values, 7 of those ones. So plus 7 times 8 to the 0th. And so looking at all of these placeholders, 3, 2, 1, 0, all I'm taking are the coefficients here, which would be 1, 6, 3, and 7. It's base 8, so I put a little subscript of 8. All right. You might not find this to be a very useful algorithmic approach. You may not want to do it this way, and you don't have to do it this way. I just thought it would be nice to give you something that at least connected to how we were doing it with the Babylonian approach, which we'll come back to, the Mayan, right? Anything that involved a place value that was other than 10.